Advanced Algebra, Chapter 13, Lesson 2, we're going to begin looking at trigonometric functions by starting to look at angles on the unit circle. And again, I'm going to use a pre-calculus video to introduce this. In the first video here, you'll hear me talk about radians and degrees and how to convert from one to another. I don't really cover it, but we will cover that in the next lesson. So just be aware that when I'm talking about that, that's not necessarily something in this lesson that you'll need to know, but we will cover it in future lessons. So the first video is an introduction to trigonometry. Chapter 4, Lesson 2 of Pre-Calculus, we'll be looking at trigonometric functions of acute angles, and we're going to be using acute angles from some special triangles that we learned about back in geometry. You remember we looked at 30, 60, 90 triangles, and those had special trigonometric ratios associated with them, sine, cosine, tangent. And then we looked at the 45, 45, 90 triangles, what had special relationships when we looked at sine and cosine. And what we want to do is bring those triangles now and place them in the coordinate plane, because once we do that, the power of those relationships is really opened up and becomes applicable to a lot of different sciences and studies. So it's a very important topic of study. So we're going to spend a couple chapters and a couple in the next few weeks talking about these types of things. So the first thing we want to do is talk about those angles and where they're going to appear in the coordinate plane. So what we have here is a picture and what we're going to call a standard position angle. And an angle is considered to be in standard position when we place the vertexes at the origin, and one of the rays of the angle is the positive x-axis, and the other ray side of the angle is this ray that gets rotated around the circle, and this is called the terminal side, because wherever it stops, that's called the terminal point. You've heard of terminal can also mean where something ends. So as we rotate this side around this circle, one side of the angle that we're looking at is always going to be the x-axis, the positive x-axis. The other side of the angle is always going to be wherever this side stops, okay? Now, you'll notice I can rotate counterclockwise and I can rotate clockwise. And you'll notice that I can have acute angles if I stop here in quadrant 1. If I get over here, it's obtuse, and then what happens when I go over 180? This might be something, might be a little bit new, but hopefully you can catch on. This is still an angle. It's just 180, but it's gone a little bit further. So we're looking at how far it's rotated, and so this is an angle that's more than 180 degrees. Alright, and this can continue to rotate all the way around until I get all the way around back to here. Now this is where, if we're talking about degrees, how many degrees is half a circle? Well, that's 180, you remember. But what is that in radians? Remember, we want to start making that conversion. That's that conversion that we talked about. Now that's pi radians, or 180 degrees. Now if I continue to go all the way around the circle, how far have I gone? I've gone 360 degrees, or I've gone 2 pi radians. Now if I continue to go and continue to add that up, now I've gone 360 plus another 180. So that's 540, or how many pi's is that? Well, pi, 2 pi, well now that's 3 pi radians. And if I went all the way around again, that's 360 twice, so that's 720 degrees. And what is that in radians? Well, that's half a circle is 1 pi, 2 pi is once around, 4 pi would be twice around. So you'll notice that actually I can keep rotating this and keep adding those angle measures up as I keep going round and round and round. Now, hopefully some of you notice, well, if you can go this way, can you rotate the other way? Well, yes, we can. So this would be pi degrees as well, or pi radians, excuse me. But how do we tell if we went positive, or well, I just gave it away. How do we tell if we went counterclockwise or clockwise? Okay, so here's an important point. Counterclockwise, the angles are positive. So this would be a positive 180 degrees or positive pi. If I went negative, or I went clockwise, that's considered negative. So this would be negative 180 or negative pi. So counterclockwise is positive and clockwise is negative, which is a little counterintuitive to me because you think clockwise is the way we should go, so that should be positive, and counterclockwise is not, so that should be negative, but it's the opposite. So counterclockwise again is negative, clockwise again is positive. Okay, so this is an angle in standard position. Now the angle that we're interested in is this central angle. This is the angle that we'll always be interested in. And when we talked about in that last lesson about 45, 90s or 30, 60, 90s, this is the angle that we're talking about. So this will be a 45 degree angle or a 30 degree angle or a 60 degree angle. And if it stops where this ray stops on the quadrant, okay, that's that quadrantal angle or that pi over 2 angle. So this angle that's created from the initial side to wherever the terminal side stops, that's the theta that we're interested in, and that's the measure of the angle that we're interested in. This is the Greek letter theta, and we use it as the variable for an angle when we're talking about trigonometry or in mathematics. To wrap this lesson up then, let's look at the 6 trigonometric functions that we'll be dealing with over the course of the next few weeks. And these come from the triangles that we learned about in geometry, the 30, 60, 90, and the 45, 45, 90. We work with the first 3 that we're going to look at. The first one is what we call the sine ratio, spelled S-I-N-E. Its shortened form is sine. Now, this is the Greek letter theta, and theta is a variable. It's like a letter. We use x, they use theta. Theta is a letter. So this is a letter, and we use it to always represent an angle measure. So the only value that you could substitute in for theta at this point would be the measure of an angle, either in degrees or in radians. So the sine of the angle is equal to, and then it's the opposite side over the hypotenuse. Okay, and then you remember we had the cosine ratio, so the cosine function. So again, we have the cosine of some angle is the adjacent over the hypotenuse, and then we have the tangent ratio, and we abbreviate that tan, and again theta, a variable, and that is the opposite side over the adjacent. So hopefully you remember those. Alright, this is the old SOHCAHTOA thing. Okay, sine is opposite over hypotenuse, that's so. That's cosine is adjacent over hypotenuse, and then tangent opposite over adjacent, SOHCAHTOA. That helps you remember. Now, there are 3 additional functions, and they're reciprocals of these. And if you make the connection between them, it's a little bit easier to recognize. So, the reciprocal of the sine function is what we call the cosecant function, spelled cosecant. Its abbreviation is CSC. And the cosecant is the reciprocal of this. It's reciprocal of function. Now, you'll see this written as 1 over the sine later on. And we'll just do it now because, we'll just introduce it now. So, because it's the reciprocal. So, the cosecant is 1 over the sine. And what that does is the ratio then is the reciprocal of this ratio. So, the cosecant ratio would be the hypotenuse over the opposite, because they're reciprocal functions. In the cosine function has a reciprocal, and that's called the secant function, and that's abbreviated SEC. And again, the secant is the reciprocal of the cosine, so 1 over cosine theta, or it gives me the reciprocal of that ratio, so it's going to be hypotenuse over adjacent. And then, of course, we have, we're going to move this down here, the reciprocal of the tangent function is the cotangent function, and that's abbreviated COT, and again, it's the reciprocal of the tangent. And so what it does is it flips that tangent ratio over, so we're going to get adjacent over opposite. So these are the 6 trigonometric ratios and functions that we'll be looking at. The sine, the cosine, and the tangent. We'll spend a lot of time working with sines and cosines. We'll spend a little bit less time working at tangent, and we'll spend even less time working with these because we can apply sine and cosine and tangent to most data that we want to look at, and these are simply the reciprocals of it. We can pretty much represent everything we deal with using these 3 functions. But it's good to know what these functions look like, being the reciprocals of these, so we will spend a little bit of time with those. Okay, so that is a summary of the trigonometric functions which we will be looking at over the coming weeks, and we'll take a look at those more closely in the next video.